Hello everyone and welcome to our lecture for week 10. This is going over chapter 10 in the book. We're finally matching in terms of chapters and weeks. This week we are going to go over just some final stuff about some what's called vanilla JavaScript, which is just your basic JavaScript. That's basically going to be some additional language features, so things like array functions, prototypes, objects, stuff like that. And then also asynchronous APIs, and then browser APIs and external APIs. There will be some caveats to the externals. Actually, I think I might have taken those out. I did. So we're not actually going to go over, I apologize, there you go. We're not actually going to go over the external APIs for mapping and charting. Stop it. There we go. Because the ones that were in here / in the book are not free anymore. The Google Maps API, you have to sign up and then it charges. And then the plotter.js, I believe is still free, but so it's something you can check out if you want. We can take a look at it at the end of the lab. I apologize if you hear me drinking. Allergies are kicking my patoot, so got a little throat thing going on. All right, so first thing we're going to talk about is array functions. So these we're going to go over in greater depth in the next couple of slides. But for now, this is the basics of what they are and what they do. So we have for each, which iterates through an array. Think about for loops. We have find, which is kind of a mapping, like sorry, let's not use mapping here. Let's not use it because we're going to actually use a map. So it's like a search, right? So you find the first object whose property matches something, right? Filter finds all matches. So find finds the first, filter finds all instances of it. Map, kind of the same as filter, but builds a new array out of it. And we'll go into that in a minute. Reduce reduces an array to a single value, which sounds confusing, but we'll go over it. And then sorts a one-dimensional array. So a one-dimensional array means that there's no nested arrays in it. So it's just one array, right? Okay, so let's take a look at them. So for each. So a for each works like a for loop, but without the iterator. Okay? This one, so this one calls a function, and that function will be called for each element in the array. So the example is in our book. No. Let's go back here and then boop, 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 boop. Free sound effects. Go away. Yes, thank you. Yes, thank you. Please open the book. Because it doesn't have the exact same that I wanted to show you all. So let's see here. Chapter 10, array functions. Let's close this. All right, so these are the different ways to do for eaches, right? So in this case, we've got an array of paintings. Well, we've got a constant that has an array of arrays, right? Called paintings. Okay? So version 1 was a for loop, right? And this is the one where we set up the iterator at 0, iterate through for the length of the paintings array, and then I++ do the thing. Okay? Version 2 is using for and then let p of painting. So you call the array in the for loop. Version 3, it's got two different examples here. Pardon me. So you do paintings dot for each, and then call the function. Now, for each is a method, and so does have to have a function to call it. So, but it's basically what this is doing. So, for each function p, whatever, console log p.title by p.artist. So we have a title here, artist, year. So for every item in that array, it would console log the title and the artist for it. Version 3b is the same thing using arrow syntax. Because I want you all to get arrow syntax because more and more people are using it. So I don't want you to get confused when you see it in other people's code. And I also want you to get comfortable using it. Our lab uses it in there for fetch because it's built into fetch. So this one is paintings for each, anonymous function, because it's not a named function, that is passed a p variable. And then do this, console log title by artist. Same kind of thing, right? So that is old way you used to do it. For set up your iterator, set up your length, and then iterate it one time. Newer version, let p of paintings, which is what we've been doing so far, and then for each. Okay? Big thing to remember about for each is that it is a method, so you need to pass a function through it. But they all did the same thing. Okay. Yeah. So that way it just shows the arrow syntax. I just wanted you to be able to see all of them. Alright, so find. So we had find and filter, right? Find is the first object that matches something. So we're using that same array of paintings. So, stop doing that. There you go. These are our items within the array. And we're creating a variable called Courbet, which goes into the paintings array, and then find, and then again, it's a method, so you have to pass a function through it, which is why we're using the arrow syntax. So this is within that array, find the array item artist that matches Courbet. And then log Courbet title. Because we have Courbet set here, so to find the thing, and then log the title of the item. So when it's finding that item in the array, it is finding that whole item. So in our paintings array, it has 3 attributes or properties. You know, it's got the artist, the title of the painting, and the year. So when it finds that first one, that the artist is labeled Courbet, then it is going to grab that whole chunk. So it's Courbet, burial or non, and then whatever the year was. It's going to grab that whole thing so that you can grab different attributes from it. Like it says down here, the find method is passed a function. This function has to either return true or false. So basically, if it matches, do this. If it doesn't matches, do this. In the example above, in the one we were talking about, it returns a result of if that artist name exists in the array. In general, when you are using find and filter, you're going to need some sort of catch statement. Because if you put in there artist or P artist equals Warhol, it's not in the array. So it's not ever going to do anything. So it's good user interface and user experience practice to, if there's a possibility, even if it's the smallest possibility, that the thing that you're searching for could not exist in the thing that you're searching, to put a fallback in there that says, hey, this does not exist, do this other thing, or letting the user know that, hey, this doesn't exist, so that your user's not sitting here thinking, oh, was the whole thing broken, or did I just type in the wrong thing? What's going on here? So don't let your users get lost. Think back to our don't make me think. They're going to get lost if it just sits there. Okay? All right, the next thing is filter. So filter is find plus. So filter finds all of the matches using the filter, or all of the matches that match whatever you're searching for. Since both of them since they both need to either return true or false, this is where you could also use regex, which we talked about last week, to do more complicated search results, because they're obviously either going to return one or the other no matter what. It's important to remember on this one that since you are returning a multiple option, that it is going to return an array of objects versus just an object, one object. For find, filter returns an array. So one versus many, find versus filter. Okay. Array map. This is a really cool way to take things and transform them, which is what we see here. So what they've done here is it's basically filter plus. So find, filter, map, right? So what they've done here is they have created a constant named options that takes the paintings array and creates a map of it. And the map says, do this thing, create a new array of the same size as the original thing, and transform the values, right? So what it's doing in this one is it's, for each of the items in the paintings array, it is creating a new list item, or creating a list item, and then adding the text content to it as the title of the item, and then parentheses, and then the artist name. So when it returns, and then returns it, right? So when it does that, when it actually runs the options here, this is what it's going to output. So girl with a pearl earring, Vermeer, artist holding a thistle, Durer, wheat filled with crows, Van Gogh, burial at Ornans, Courbet, and sunflowers, Van Gogh. So that's why you would use the filter if you were searching for Van Gogh versus the find, because there's two. Make sense? Also, my previous college work, slight tangent, I was going to be an illustrator before I got into digital media and programming and web dev. If you're really into some really, really cool like nature drawings, looking up Albrecht Dürer, he has some really cool stuff. I would highly recommend checking him out. Same with Vermeer. He's really famous for using a lot of like blue in a really cool way. In tangent. Alright, so reduce and sort are the ones that can be the most confusing. Okay? So reduce takes an array into a single value. Okay? So, like the others, it is a method, so it's going to take a function and pass it. And what it does is basically returns a value. Okay? So think about this in terms of if you have like a numerical amount that you need to add, or you could also append strings to it, right? But for this one, our paintings array has a value property of it for each painting. I didn't show it in the example, but we're pretending. Okay? So we're setting our initial value to 0 because for this function, you have to have, it takes 4 values, you have to have 2. Okay? So we're setting the initial to 0 because for our first one, we're not going to have a previous value. And then we're going to add that to the other one. So let me go back to our book because this slide is not extremely helpful. Let's see here, for each, filter, map, and reduce. It doesn't really help there. So, basically, with this, we are calling a function that passes through a previous value and then a p-value. Our previous value is going to be set to initial, and then our current value is going to be set to the previous value plus the p-value. I wish I had a little whiteboard, but I don't. I will try to put some, that's not the right thing at all. I will try to put some examples up in our resources area, and if I don't, just yell at me and remind me. But that basically is doing a math operation for you. Yeah. As you can tell, I don't use reduce a lot. But basically, you know, it is taking the paintings array, reducing it down to a single value. So at the end, you will end up with one value that the total returns. It takes a total of 4, which is why we have 2 here, because you have to have the 2, which is the previous accumulated value and then the current element in the array. So previous is the current previous accumulated value. P is the current value in the array. And then do the thing to get your cumulative total. And so for that here, we are taking initial as our previous, and then adding the p-value to it for the first one. And then the next one is going to go back and go through again, grab that previous value. So let's say the value of the first item in the array was 1. Then it would be 1, and then p. So it would do the second one, and then whatever the value of the second one, and then p, and then blah, blah, blah. I apologize again, that's freaking mouse wheel. But it just goes through and iterates through and then totals everything. Alright. Sort. Sort always sorts in an ascending order. Sort only sorts as strings if necessary. And then sort only sorts a one-dimensional array. Sort would not be able to sort our paintings array, because a paintings array is a two-dimensional array. Yeah, it's a two-dimensional. A one-dimensional array here is like names. So we have Bob, Sue, Ann, Tom, and Joe. It's going to sort them alphabetically ascending. So it's going to start at A, go to Z. Right? So, and then if you need to sort an array based on one of the item's properties, you will need to add the sort method with a compare that returns either 0, 1, or -1. And the way that that works is you compare two things, and then if they are equal, then it is set to a value of 0. Excuse me. If the first is greater than the second, then set it to a value of 1. And then if the first value is less than the second, set it to a value of -1. And then you can sort it, because then it's all just sorting those values, right? Versus sorting the array objects themselves. Because it's set by default to sort the array objects, not the array object properties. And then this is an example of a custom sort, which is what we were talking about. So this is using our paintings. So sort the paintings by year, right? And then this is going to return an array of paintings by year sorted. And then those paintings dot sort. Sort is again a method, so it's going to be passed a function. We're doing a function that takes A and B because you were checking two values, right? You're checking A and B against each other, right? So if A year, so your first item year, is less than the B item year, return -1. And then if it is bigger, return a 1, and then else return 0, right? And then the last example is a more concise version that uses our ternary operator, which is that question mark, and then if yes, -1, if no, 1, and then arrow syntax. So you can see how it can get very confusing very quickly if you don't understand arrow syntax and then the ternary operator. It just looks like a bunch of letters here. But the way that this works, if you think about it, it is iterating through the array and then checking and sorting things based on that one at a time. Alright, so that is sort. So you can do it just by the objects themselves if you don't have object properties. And then if you have object properties, just keep in mind you're going to have to use a custom sort. Alright, prototypes, classes, and modules. So, I want you to think back a couple of weeks. So, a couple of weeks ago, you used a constructor function to make multiples of a thing, right? We did this in our picture one, where it was like this dot blah returns this, right? The problem with this, with using the constructor functions, is that every time that function runs, so every item in that array has a memory allocation for it every time. So if you have an array with 100 items in it, then you are using the memory allocation times 100. So that's the example here on the right. So it has 100. Each one is 920 bytes and then 80 bytes for, like, it's 920 bytes for the markup and then 80 bytes for the item itself, so, which is like 1,000 bytes. You have 100 of those. That is 1,000K of memory that you're going to have to, or 100K of memory, 100,000 bytes of memory that you're going to use up. You ever have like a Chrome tab that you're opening and it takes forever and ever and ever? That's because Chrome eats memory. So, prototypes helps a lot. Alright, So prototypes basically take JavaScript and make it to behave more like an object-oriented language, so a little bit more like C#. This is even more true of once you get to classes and modules. This is too small, it's cutting it off. Okay. So each function, each object in a function object has a prototype, which is just an empty object, right? You don't have to make use of the prototype empty object. In that case, it just stays empty. But if you want to, you can do it. And then once the prototype properties are defined once, every instance of an item, an object with that keyword of whatever prototype we're using uses that same one. So instead of, having, in the example below, you had the markup that was 920 bytes, and every time you had an item, it was calling that 920 bytes. Well, with a prototype, you have your items. So in the example here, they're 80 bytes each. So you have 80 times 100, which is 8,000. And then you have your one instance of the prototype, which is 920. So it rounded up here, but the total memory usage would be 8,920 versus that 100,000, right? That's a huge difference. That's basically a tenth of the memory that you're using. So it's way better for memory usage. It's also easier on you. So, how do we use it? Okay. So we use the dot prototype, and we use it in two ways. We do dot prototype dot make markup, and then we use dot prototype and make whatever, right? So, what we've done here is we've set up a function called card that takes 3 items, title, source, and content. And then we're creating with that card function object a prototype object. So let's look at the markup first. So card.prototype.make markup. What that does is this is the basically your inner HTML, right? So it's a function, it's got to be called as a function, and then it returns your markup. So in this case, it's returning a div with a class of card, a source with a attribute of this.source, okay, and then an alt with an attribute of this.title, and then an h4 that is the title, and then a paragraph tag, which is the content. So those are all things that we are passing through our card function, that every time it's going to generate this markup, okay? And then we actually make the elements. So card.prototype.make element, again, pass it a function that is going to return a thing, right? Well, what is it going to return? Well, it's going to return card div. So let's look at card div. Let card div equal div equals, it's creating your elements divs. So you would have to do this. It's got the ... because you would have to do this for all of your elements, right? So it would basically be let whatever image equal document.createElement.image, or image, and then the same kind of thing. And then you actually use the prototype. So the way that you do that is, this is a little bit different than the way that I would do it, because they're making it fit in the area that they have. But I would set up your query selectors outside of your onload function, like we did in our lab this week. But it's got a query selector that grabs the container ID and then sets that to the container variable. And then a constant called C1 that is a new card. So it uses that prototype with the attributes of Van Gogh. This is their source. And then this is the content. And then appends it. So you would create as many of these, you know, would have like a C2 with a different one, C3, and then just append those. I can tell, because I had the same kinds of questions. Well, why wouldn't you just hard code that in? Why wouldn't you just, if you have your array of objects, why wouldn't you just write that into your HTML when you're writing your HTML? And the answer is because there's a couple of reasons. The first being, if you do it in your JavaScript or jQuery, you can do it after the rest of the DOM elements have loaded, so you're cutting down your load time, which is great for things like images that have a heavy load time. The second thing is, well, what if you're tying it to content that's dynamic? So, think about forms. Have you ever gone to a page and there's a drop down and you're like, oh, I want to see stuff based on this, right? But you don't want it to do a whole nother page load or go to a whole new page. You just want to write that HTML based on that choice. That's when you would use it. So our program finder on the front of our web pages is a modified version of that. It has the first choices built in, and then it populates that second drop down based on your first choices. So you don't know what those second choices are going to be until somebody makes their first choices. So if you have them built in your JavaScript, then you can put those in. So those are the reasons why you would do this versus just like writing out all your possible options shown on in your HTML. Okay, so prototypes can also extend other things. This is very close to if you're used to like C#, if you do any like Unity programming, if you're in our game dev class or something like that, or AR class. Actually, I don't know if they still do it in AR. But basically, you use your pre-built prototype and can use it within other objects to do the same kind of thing. So in this one here, it is using the string object to extend the prototype of count characters. And what it's doing is, if the character at whatever index it is, add to the count and then return it. So we're passing through the message of hello world, and then doing the count characters on the string, and has like how many instances of the letter L is there in it. So it's going to return 2, right? Another example of this is in your book, which I think explains it much better. It basically extends their card prototype that they've built to use for a new type of prototype that's an animated card that adds an effect to it, like an animated effect. So make sure you read your chapter because it's really useful. Okay, classes. So, classes are basically moving JavaScript towards semantic syntax. Well, less, not really semantic. It's moving it kind of in line with other programming language syntax. It doesn't actually change the functionality in any way, but it's becoming more and more popular in things like React and like Rust and stuff. So I need you to be aware of it. But what class does is that it allows you to construct a function and a prototype using the class syntax instead of using function syntax. Let's take a look. Okay, so here, whereas before we had a constant card, this is a class card, and then it has class methods instead of prototypes. So this was constant card equals whatever. Let me get back to it. Blah, blah, blah. Boop. Sorry, function, not constant. Function card takes a title, source, and content, returns those three, and then card prototype dot make markup. So let's take a look back at the class. This is a class card. Notice it is not a function, so it does not have that to put in before the brackets. Instead, it has this thing called constructor, and that's where you put the function constructor in, right? So instead of having function card parentheses title source content, you have class card with a constructor of title, source, and content. Does the exact same thing, just where it is. And then instead of having card.prototype.make markup, we have class methods. So it's just make markup, open parentheses, close parentheses, make element, open parentheses, close parentheses. It does the exact same thing. And then to use it, you do the exact same thing, right? So down here, when you're actually using it, when you're appending those, it just says new card, right? So, sorry, mouse wheel, stop. Okay, I'm just going to use my arrow keys. So this, constant C1 equals new card, same thing, append child versus constant C1 equals new card. So it is the same thing, different syntax. But I just want you to be aware that it is there and that you can recognize it if you come across it in someone else's code. All right. Extending classes. Oh, I apologize. I was thinking of extending classes when I was talking about extending objects. So this is an example of extending a class. Like, this is using the cards class to create a new class called animated card. So this is what I was talking about. And you see this a lot in like C# or Java. So basically this is creating a new class called animated card that extends our old class of card. And our constructors here have the title, source, and content from the old one, but also an effect one, right? So that fourth one is new. So the super keyword here means that take these things from the one that we are extending. So we're taking the title, source, and content objects from that card, and then in this case set the effect to this new thing called effect, right? So you use the extends keyword and then the super to pull in what you want to use. So with a class that extends, you've got a couple of more things. With just a class, you've got your class name, and then your constructor, which are your arguments that you're passing through. With an extended class, you've got your class name, what it extends, with the extend keywords in there, and then you've got your constructor and your super. Okay. So what happens when you have a super complex file, and it's got all of these different JavaScript files in it from all these different libraries that you're pulling in, and you try to name a function or a variable, but they're named the same as like two other different files that you're pulling in, and there's conflicts, and oh my goodness, it will break. Well, the way that we fix that is with something called modules. So a module is a file that contains JavaScript. That's all it is, right? The difference is that when you add that type equals module to it, that all of the literals described in it, so, all of the names of your functions, all of the names of your variables, those are only scoped to that module, right? So, if you have module A that has a function called do this, and then module B with a function called do this, then you can use those both as long as you use the attribute in there. Okay? So let's take a look here. And this is how you use modules. Okay? So we've got 3 files here. We've got tester.html, we've got painting.javascript, and we've got artist.javascript. In our tester.html, we are creating a module that is importing the painting.javascript file. From it, we are importing the work from it. Okay? And then we are going to console log the work.format painting with this given thing. And then we go down to our JavaScript file because we're looking for work.format painting from painting.js. What is that? Okay, so we go down to our painting.js file and we're looking for something called format painting. Okay? Well, format painting is this function right here. It takes a title, first, and last. I'm assuming name. Does this thing called totally private. And then says let artist equal art.format artist. Well, where's art? Huh. Okay, so we got to go back. We are importing as art, or porting all as art from artist.js. So in that case, it goes down here and grabs this. So we're looking for art.format artist, right? So we do this, we go down there. I can be called from other modules, also private. I can only be called from within artist, and then create artist image. So it's going to go and grab this thing from the artist, and then it's going to return title by artist, right? And then the painting image and totally private, it's not being called, so it's not really going to do anything. Well, totally private is, create painting image is not. So it's going to console log, I can be only called within painting.js. And then down here, when it imports this, it is going to call the also private. I can only be, or sorry, it's going to call the stuff within the function first, and then the console log down here, and then it's going to go down and export. So to use modules, you import to use things from other modules, and then within the module itself, you export so that they can be used outside of the module. Kind of a confusing concept, but the more you use it, the more you'll get used to it. It just helps to avoid naming conflicts. Alright. So let's talk about asynchronous code. So when you are running your programs, when you're running your scripts, the way that it works is the amount of things that you can do is determined by the number of threads that you have. So each thread can do one thing at a time. Some operating systems are multi-threaded, which means that it can run multiple threads at a time, so it can do multiple one things at a time. But web browsers are not multi-threaded in general. So we can only do one thing at a time. So what do you do if you're making a call to something or doing something in your script and you know that it might take some time to get something back? Because if you're calling out to another server, it might take time to get a response back. But you don't want to tie up that thread because you've only got the one. And if it's sitting there waiting for that response, your user is just going to be sitting there waiting for it to load, right? So what we do is we use asynchronous, which is basically like, I'm going to do this while I'm waiting for another thing to happen, and then switch back when the other thing happens. So let's kind of take a look at normal and then what it looks like asynchronous. So normal, right? You make your request, you get your response. After your browser receives your response, it makes a blank window, and then it renders the HTML, and then the user selects a country, and then it makes another request, makes a new window, and then browser receives a response and then renders. So you make a request, you get a response, you render. You make a request, you get a response, you render, on and on. Now, what about with asynchronous, right? Well, you make a request, you get a response, browser makes your response, creates a blank window, and then renders your HTML. User then, so in this case, we have our thing here, our form, and in this case, you have to hit update after you do that to make a new request. In this case, you make a choice, browser makes an asynchronous request because something has changed, so it's going to take that request and then returns data. So in addition to deferring things until they're loaded, you can also, like the example I gave before, dynamically update documents based on choices users make. So forms are a great use of this. The other uses of this are web APIs. Well, APIs in general. So let's look at that, and then we're going to look at how things are asynchronously requested using our web APIs, right? Okay. So in our lab, it shows the old way of using an API to make a call. In our book, it uses fetch because fetch is the new way. And then if you're using jQuery or Axios, there are even newer ways. So let's do a thought experiment here. Let's think about a page containing a select element, which is like a drop down, right? And then with this drop down, you have a country list. And with the country list, there is a event handler that, when it is selected, checks that value. And depending on the value, is going to fetch something from an API that's going to return the list of cities for that country, right? Pretty typical use case. So the way that works is you have a fetch with a URL and then your variables or your properties or your constraints in it. Okay. The point in this one is that when you fetch data from a web API, it doesn't automatically populate, right? Because sometimes it takes time for it to execute and respond, right? So the way that they get around that is by using promise objects. So there's two methods that you tend to use with promise objects, and those are the then and then the catch for it. And in our lab, you'll see that we have two then statements and then a catch statements, and so that that is the way that you handle that sort of asynchronous data loading. And a lot of times, while that promise object is being filled, while we're waiting for that data to return, you do like an interstitial loading screen or a loading animation. So you let your user know, again, that, hey, I'm looking for a response. Please don't leave. I'm actually working on it, kind of thing. Because in the instance before, when you do that web API call to grab those cities of Italy, it's different than if you just had different arrays built in that already had those that you could just pop in, because it's got to take that time to reach out to that other server. So promise objects, then, and catch allow your implementation of different strategies to let your user know that, hey, we're getting this information, just hang on a sec. All right, so asynchronous request using fetch, right? So let's kind of take a look at what we have here. We have some HTML up here. So we have a select ID with countries, select a country, and then, so this is a drop down saying select a country. And then we have our script tag here within event listener on DOM content loaded. That is a function. And then a constant of an API URL that grabs, that part of the URL is API/countries.php. And then a constant called country list that goes and grabs the things from the countries, the whatever it is with the ID of countries. And then we have our fetch statement. So this is where it's actually making that call for data. So we're saying fetch using our API URL. Now this is not a browser API because that is not a full URL. So fetch using this URL, right? Okay, so it's going to go out and reach out. Then, while the response is getting received, do this. Okay? So, this will execute when a response is received. Then, what do you do with it? So the actual data from this, the response is going to be this up here, the JSON data. Then, so you got a positive response back. Then with that data, for each of them, create an option or an element called option, set the attribute value to the ISO, which is your country code, and set the text to the name, which is the name right here, and then append it to the country list. So this creates those new options in our HTML. And then, oh, what happens if it messes up or it doesn't receive a positive response? Then do the catch statement, which is like, oh no, if there's an error, write that error. Okay? So it's a little bit different than the HTTP request cycle, because it is not just sitting and waiting while we're waiting for that data to populate. It is doing other things, but then when it gets the response, do this thing. All right, so what are some common mistakes with fetch? So something that is explained in our book is multiple nests in fetch. So multiple nests in it can be really, really problematic. So in this one here, we have let fetch data, fetch URL, then the response, and then the data, fetch data equals data, right? Well, the problem is that this is calling a method, a function that is never, that it tries to call it before it exists. So while these then are just hanging out, it's going to go try and do this, right? So it's going to do, create this variable, go fetch the URL, and then we're waiting, hanging out for the response, go do the next thing. Well, we can't do that because it's using this variable that we're setting within the fetch, but we haven't received the fetch yet. So if you're using any of your fetched data, you need to make sure that you're using it within your then statement. So it's just kind of going back to our old thing of you can't create or use a thing before you've created the thing, right? All right. Cross origin sharing is a huge thing. So basically it's saying that when you use a website, or when you make a website or a web page, if you're trying to pull in data from a different domain or a different protocol, so if you're trying to call an HTTP page from an HTTPS, or a different port, which is way out of the scope of this class, it's going to block that. And you may get in your console a thing that's like cross origin blocked. So just know that if you need that kind of thing, you just need to add this access control allow origin to your header. All right. So we're just going to briefly go over this. So, most of your fetch responses are using get, right? Sometimes you want to use post, or sometimes you want to use put, or sometimes you want to use delete. So like a post would be to add something to favorites, add something to a cart. Basically, when you're wanting to add something, you do a post. A put or delete, you don't really use that much. So you just have to use a different syntax to use that. And we're not going to go over that because, again, outside of the scope of the class, but just know that there are different methods to use it. In general, you're going to use get. Post, put, and delete are like for messing with a database server. And, again, way outside the scope here. All right. So, fetching takes time, right? Right. So, this is talking about the loading animations. So, you add a loading animation while the data is being fetched. And the way that you do that is super easy. You have your animation in there, and then before the fetch, you hide your content box and pop up the animation. After your fetch, in your then statements, when you get your data, you just switch it back. You turn it off and on. It's just hiding and showing. And that is, again, best user practice, because if you don't do anything while that user is waiting for your data to load, they don't know that and they think your site is broken and they will go elsewhere. So just know that if you're using any sort of fetch or anything that may take a minute to load, to have that sort of loading animation in there. Okay, this is more about promises. So a promise is a placeholder for something that we don't have now, but we're going to get. So, oh, I got a typo. Boop. Okay. So eventually it's going to get completed. So the then are promises. So client makes a request via fetch. Fetch is like, hey, please give me my data, right? Please give me data. While that's waiting, fetch provides a promise. So the then client does other lines of code, and then finally that server's like, oh, hey, here's your data. Fetch then notifies the client that the data is there. The function that in your then statements is done, and then is passed the data, right? So this is your call, does other stuff, response, does, oh, we've got a response, and then your data. And then if this fails, this is where your catch statement happens. Well, it actually happens about here. So if 5 fails, it's going to notify that there's a response. It's just not a good response in terms of like it's a 200 or a 400 response. So that's why you should have that catch for error handling. So how do you create a promise? Well, it's really easy. You just make a promise object. So this is the breakdown of it. This is how it's actually used. So a promise object is an object that has a resolve and a reject that's passed through it. And then within that promise object, if some condition is made, then that resolve object does a thing. Otherwise, the reject object does a thing. So like when we're using our fetch, the then is a resolve object, and the catch is a reject object. So promises basically exist to have two states, either resolve or reject. And then while we're waiting for those 2 states to happen, you can go do other things. So let's look at an example. All right. So, we've got a function of transfer to cloud with a new promise with a resolve and reject that has a URL. And then if the file name exists on that URL, then we're going to transfer the file name to the cloud URL and then resolve the cloud URL. Otherwise, reject with an error, right? So to use it, you have transfer to cloud. So this is your fetch file. And then the URL, extract tags, compress image, and then if it doesn't work, console log this error, right? So it's saying transfer the image to a cloud storage environment, Use the machine learning service to extract tags, and then create a compressed version of the image. You can have an array of promise objects as long as they are targeting different objects. Okay, so that's what we have here. We have one that's targeting the movie API, one that's targeting the ARP API, one that's targeting the language, and then you can do them all at the same time. And then when it's done, do this thing, right? You cannot have multiple promise objects that target the same thing happen at the same time. If you try, it will fail. So what do you do about that? Well, you can use async and await keywords. So, like, this helps eliminate nesting, and then, like, helps with your multiple promise, right? So let's look at, I think there's an example in here. Yeah. All right. So the await keyword basically says that you return promise objects as if they were synchronous. So the object will contain whatever resolve functions that the fetch has, which is a response from the fetch. We don't need a callback, right? Now, the thing about await is that you have to use it with a function that is prefaced with async. And I would look in your book for a better example of this, like a more in-depth example of it. Goes over those asynchronous requests and then await keywords. But it's basically like, hey, I'm going to set aside some processing because I know this thing is going to happen, but it's not going to happen in the normal DOM load, that kind of top-down, top-to-bottom load. So I'm going to wait for it, right? All right. So let's look at some browser APIs. So the difference between browser APIs and external APIs is external APIs are usable offline, usable outside of a browser. That is the difference. So that's why the URL in those didn't have a full URL. Browser APIs happen just inside the browser. You have to be online to use them. So there are a couple different ones. We're going to be using a weather one for our lab, but these are a couple examples of other ones. So we have a web storage API. So that is basically a way to keep data even across sessions. So if you've ever heard of things called cookies, right? So cookies are little bits of data that get stored on your browser, because they don't go across browsers, across sessions until you clear your cookies. That's a web storage API. Local storage is one that lasts until they are removed. Session storage are ones that last but only through that browsing session. So if you close the tab or close the window, then a session storage item object goes away. So you use these by calling set item to either local storage or session item, and then to get them, so you add things with set items and then you get them with get items, right? And where can this be helpful? Well, this can be helpful for things like your shopping carts, your favorites lists, your stuff like that, until you actually load it into your database. So these kind of live on the user's computer until they get rid of them, or until you get rid of them by putting them on your database. I apologize. I don't know why I had that on there twice. All right, the web speech one is for text to speech and speech to text, both ways. Really, really cool, right? Really cool. So to take a piece of string and put it into text, you use the speech synthesis utterance and speech synthesis objects. For the other, I don't know them offhand. But you can adjust the speed and pitch of the speech. You can adjust the voices. But this is how, if you ever go to your website, I think Canvas even has this built in. And it does text to speech to where you can click on the little speaker and it'll read it to you. That is using a web speech API. And there are different ones out there. And then finally, a geolocation one is one that allows you to obtain the user's location. Now, there's a small caveat. So that is only accurate depending on the device and depending on the permission level and depending on whether or not the person is using a VPN. Because if you're using it on your computer, it's going to do it by your IP. And IP can have a pretty big range. If you're using a VPN to set your location to somewhere else, that IP is not going to be accurate, right? If you're using your phone, it's going to be much more accurate. But it may depend on what permissions are set in your browser or app or whatever you're using it on to whether or not you can get that location data at all. Main point is that you can use a geolocation API to get information based on the device position. So you can get latitude and longitude. You can get all sorts of information by using a geolocation API. We're using a weather API in our lab. There's all sorts of APIs in there. Our digital displays around campus have like news APIs that we can set up. I haven't set them up, but they have that built in. So all sorts of cool stuffs use APIs. That is actually the end of our lecture. I know it was a long one. This is our last lecture of the term. I don't do finals. We are not going to have a final test, and our last lab, so lab week 10 is our final project. So just make sure that you get that in. And then we still have our extra credit if you sign up for fall or summer term, and just send me like a screenshot of your schedule or an email with your class list or whatever, then I will give you 100 points extra credit, which is basically a get out of an assignment free card. Or if you have your if you're graduating, if you did your petition to graduate and send that in to me, I will also give those points. If you're graduating and didn't send in your petition to graduate, just let me know, and I will actually, no. Never mind. You should have done your petition to graduate. No shame, but should have done it. Anyways, so that is it. Again, let me know if you have any questions. It has been a great term with y'all. I've been super impressed with the quality of work I've been getting. You've been asking insightful questions when you've had questions. If you need help outside of class, or if you have questions about like job stuff in this field, or if you get a job and need have questions that you need answers, please feel free to reach out to me. Email is bakerm@clamuscc.edu. I'm always more than happy to help in whatever way I can, whether that just be answering your question or hooking you up with available resources or finding new resources that we can find for you. So just let me know. Thanks so much, everybody. Bye.